Good afternoon, everyone. I'm Troy McDonald from WPP Energy. I'm the Global Chief Operating Officer, and we are here today to provide you a presentation on our company and two core technologies. And the technologies that we have under global license, exclusive global licenses. One of them is a waste to energy technology we call Vorax, and the other is W2H2, a water to hydrogen technology. Presently, the waste energy technology is distributed in 50 countries and is being offered by 40 distributors globally. We have aligned ourselves with world-class EPC contractors and OEMs, and we use those relationships to provide performance guarantees to our end customers and to ensure maximum peace of mind. Some of the OEM customers we are aligned with are Siemens and General Electric. Here are images of the two core products. Felix Rodriguez will be speaking later about Vorax and the various technologies involved with Vorax. And I'll be speaking in a few minutes about W2H2, which is an innovative method for hydrogen production from water, unconventional electrolysis process. Here's a quick look at the WPP management team. Most of our scientists are not featured here. We do not feature our R&D scientists to protect them from being poached from competitors. So we're going to move right into our presentation on W2H2, but first a quick look at our partners. As you can see, we have partnerships in place with UTM, Malaysia, and Green Tech, and some of the Fortune 500 players I've mentioned: Siemens, GE Baker Hughes, AEG Industrial Engineering, etc. In this list as well are logos from the 40 authorized distributors, resellers we have around the world. So we're going to go into W2H2 now. So for W2H2, we're going to cover this, but we are not going to have a question and answer session for W2H2. This is a technology which is still under research and development. The intellectual property for this technology is extremely sensitive. It features groundbreaking technology and a new method of green hydrogen production, which revolutionizes the price point upon which hydrogen can be produced. So here we state the conventional norms right now. So traditionally, 44 to 55 kilowatts of electricity is consumed through a conventional electrolysis process. Different types of electrolyzers include alkaline, atmospheric. To my knowledge, no one is producing green hydrogen right now for less than 44 kilowatts of energy per kg of H2 production. We are using an entirely different process. We are using magnetic energy, resonance frequency fields, and optical laser technology, which will disassociate hydrogen and oxygen, and will do it for about 1/10 the energy of conventional electrolysis. This will have huge implications to the hydrogen production sector and to the fossil fuel sector, and may in fact transform the entire energy sector. One of the key components of the technology will be real-time, on-demand production. So when the technology or when the hydrogen fuel is applied to a power generation setting, there will not be a requirement for hydrogen storage. That's huge. Hydrogen storage is a major problem because of the lightweight, high volume nature of the gas and the security challenges as well. So if you're going to use this hydrogen from W2H2 in a power generation setting, you can produce it and burn it in real time. So here we are talking about the savings. The savings will vary depending on which fossil fuel you're displacing. If you're going to displace diesel in diesel gensets, for example, which hydrogen is perfectly suited to do, diesel is a very expensive fossil fuel. We compare the cost of a kg of production through W2H2 at 50 cents to 60 cents, depending on the particular project per kg. And you compare that to the cost of, say, 4 liters of diesel at $3.50 to $4 American. You can see the costs are 1/7 to 1/8 of diesel. 1 kilogram of hydrogen is essentially equivalent to 4 liters of diesel fuel. As I talked about, we're looking at 1 kg of production for 4 kilowatts of energy input versus 44 to 55 currently in the marketplace through conventional electrolyzers. Now, if you're going to use the hydrogen for a power generation application, there is a wide range of values associated with how much hydrogen you need to produce a megawatt of energy. It depends on the application. Diesel genset might require 50 kilograms per megawatt. A boiler might require 55 to 65. Gas turbines like the Siemens SGT A35, 45, 65 will require 77 kg per megawatt. And presently there are, I believe, 19 gas turbines that have been manufactured with 100% hydrogen content. And there are dozens more which will run 50% or more hydrogen content. So the W2H2 solution is a no carbon solution. The only emissions we have to manage are NOx. And we do so, get them below legal limits. And we have partnerships with major OEMs who have NOx control technology. And there is a big push in the field of science right now on NOx control, ensuring that is managed. Presently, only 5% of the world's hydrogen production is considered green. W2H2 is a green method of hydrogen production. That's very important. So target markets, I want to talk a little bit about this piece. So presently, from all the hydrogen gas that's produced, about 95% of it is consumed in the petrochemical sector, ammonia being a big consumer. The implications of W2H2 are that the hydrogen will be produced at a price point which allows it to cross into new markets and allows it to redefine the share of energy production that renewables represents. So it has the potential to transform the entire sector by shifting the current consumption where 95% is consumed over here and bring it over here and start to eat into the fossil fuel power generation market share. Presently, it's too expensive to produce hydrogen to justify burning it in thermoelectric applications. The economies don't work, the economics don't work. So presently, it'll cost you $3.50 to $4 to get one. When you figure out your cost of production at 44 to 55 kilowatts. And then you figure out what you're going to get on a power purchase agreement, for example. It doesn't work. So despite the fact that it doesn't work, all the major OEMs, many of the major OEMs have spent a lot of money on research and development, getting the industry ready for players like WPP who are going to bring innovative solutions and revolutionize the price point upon which green hydrogen can be produced. So Siemens, GE, Mitsubishi, Hitachi, and Saldo, Kawasaki, all of the above are investing huge to get their equipment ready because they are anticipating key players like WPP coming forward to demonstrate that the hydrogen economy can be a reality. So with our solution, we can introduce it essentially to just about any thermoelectric environment. And our solution and our method is completely scalable. So even we can start even on a fuel mixing. If we're looking at a 210 megawatt boiler, we can start fuel mixing with natural gas and increase the H2 content as our production ability scales. So this is one of the key things we're working on right now, taking our method, our lab results, and putting it in a packaged technology, integrated technology, which is fully scalable to meet thermoelectric requirements. The W2H2 product that we have targeting the thermoelectric sector, we call W2H2 Max. It's essentially packaged in 40-foot sea containers. 40-foot sea container will have a production capacity of 2,500 kilograms per hour of H2. We've identified about 1,000 fossil fuel plants right now globally that we think would benefit from converting to hydrogen once the cost of the hydrogen production has been revolutionized down to 4 kilowatts per kg. Many of these fossil fuel plants are up for decommissioning. So we have a couple of early adopter thermoelectric clients who have 200 megawatt boilers, and those boilers are on a decommissioning schedule, and they are negotiating pilot projects with WPP to be the earliest adopters to try to keep these boilers online by doing a retrofit. The retrofit is actually quite straightforward. So the existing burners are replaced for hydrogen burners. We have OEM partnerships in place that manufacturers produce hydrogen burners. Hydrogen burnt, it's used to heat the boiler, and then the fossil fuel that used to be there is replaced. Here's some sample savings. We did some cost analysis, H2 versus natural gas, and we came up with a 50% savings based on numbers above. Those of you who want more details on this analysis, you can contact us after the show, and we can get into the economies of what a retrofit and conversion looks like for fossil fuel hydrogen, specifically H2. So we're also going to be offering turnkey power plants. So earlier I mentioned that there are 19 turbines, for example, that are going to be run for stage 2. So we have the ability to deploy, for example, a Baker Hughes Nova LT 5, 12, and 16 model, and Germany's THM series turbines. GE's got numerous turbines, power plants that are ready to run hydrogen. Furthermore, most diesel gensets can be converted to hydrogen, changed injectors, new fitting seals, and you're off the races. And in the 0.5 to 4 megawatt range, because we can get those power plants into 4 megawatt, into 40-foot sea containers, those can be mobile units. They can be put on the back of a truck if you like. Here's a sample of one of the best turnkey hydrogen turbine power plants. They have a 5 megawatt, which is really 17.5. Many of the markets in need of power, but most of you, many of you know this already. That's not unique to W2H2, simply target markets for products. We offer complete turnkey services, so someone who wants us to come in and do a hydrogen project, we're there until commissioning and beyond for service. We offer all-time contracts as well. And I spoke a little bit about the power generation side and about W2H2 taking hydrogen into the power generation sector. The transportation sector is also a huge growth area. most applications right now in the transportation sector are fuel cell related. They're more efficient than direct production. With the cost of production coming down, the implications for the transportation sector will be huge. It will take it into the shipping industry. There are prototypes and pilot projects of ships right now, merchant ships and cruise ships, using hydrogen. But this technology will take it into mainstream marine applications. And the transportation sector, along with the power generation sector, represent approximately 50% of all global CO2 emissions. This W2H2 solution is designed to eradicate the CO2 from about 50% across the world. There's some big savings with diesel. The cost of diesel fuel being so expensive, $3.50 to $4 for 4 liters versus 50 to 60 cents for 1 kg of W2H2, less than savings of 85%. Again, 4 liters of diesel fuel equivalent roughly to 1 kilogram. Benefits: zero carbon, operates at a fraction of fossil fuel, low water and power consumption. Well, the water consumption is for every 9 liters of water we take into our system, produce 1 kilogram of hydrogen. Each liter of water possesses 100 milligrams of hydrogen. It's got a lot more juice than fossil fuel. And compare it to coal, it's got 5 to 7x. Gas, diesel, 3x. And that's it. I hope you all enjoyed the presentation. Any questions and answers or questions that you have for us, you can send to us and we'll be happy to engage with you for a direct conversation. Felix, I'm going to hand it over to you and you can pick up and have a discussion on borax with the audience. And Felix is our Director of Waste Energy Solutions. Felix.
Thank you, Troy. Appreciate it very much. Great presentation on this great technology. I've been in the hydrogen technology now for quite a few years. Remember a while back, we were trying to convert cars to run on LNG. Remember those days?
Yes.
Electricity, diesel and gas was so expensive. And to transition to something like this is just really a breakthrough. Thank you. Let me share my screen here. Let's see. So can you stop sharing there, Troy? Yeah, there you go. Thanks. And here I am. Share. Let me know when you can see my screen.
Yeah, Felix, we see your screen just fine.
Fantastic. Okay. So a bit about myself. I've actually timed this this presentation to last 8 minutes. But if you like me to stop somewhere and address it, any item, please do so and I will pause it. So a bit about myself, telephone company background, AT&T, New York, Ohio, and Pacific. A while back, we started building telephone companies here in Los Angeles and a few other places, North Carolina, Taiwan, etc. And then transitioned to waste to energy a few years ago when I saw the technology and the need for a good waste to energy technology. And this has been just absolutely the best that I found. So today I'm going to introduce you to the factors that we consider when we design a waste to energy project. We'll talk about our strategy and how we get there. We'll talk a little bit about the EPA studies and what that looks like. We'll also discuss the waste, the organic waste that we process. We'll show you a plant drawing, a few of them as a matter of fact. We'll talk about the duothermal technology, the pyrolysis and the plasma. We'll talk about the flexibility in input and the feedstock into the borax. We'll talk a little bit about the process flows. We have 2 process flows for you. One is the steam generator, and the other one is a syngas generator. I'll show you a couple of the genset partners that we have and what those look like. We'll also compare the incineration and the borax duotherm results, what the differences are. We'll look again at the test results from the US EPA, and then we'll talk a little about toxic and hazardous waste residue that comes out, the slag that comes out of the system. We'll go over the solution to the waste disposal system. I'll show you a list of our product suites. We have 12 products and a brief description of them. So you see what that looks like. We'll also talk about the composition of the moisture, contents, and the kcal value, the calorific value of each one of those. Then we'll show you some more samples, and I'll show you also a 5-ton per day plant in Brazil. And we'll talk a little bit again about the terrace and the components of a waste to energy plant, what does that look like. We'll also talk about because in this system, some of the folks will want to outsource, bring in-house the EPC environment, but there's certain components that we cannot because of the IP that we cannot outsource. So we'll talk a little bit about that. We'll talk about the maintenance and the warranty, as well as the extended warranty and the training that we offer. We'll talk a little bit more about that, but we offer up to 40 hours. Then we'll show you some more pictures of a plant being delivered and assembled. And we'll go back to talk about our vision and mission, and I'll have some media links, and then I'll tell you a little bit about our team here. So to get started, we handle electricity, syngas, water treatment plants. We talk about the tipping fees a little bit more. This is very important to us because it's how we pay back. Tipping fees and electricity are our main sources of revenue. We'll talk a little about the slag that we talked about, and also about the tax credits. So the things that we take into consideration in building a plant is the needs of the community. Where are they? How are they? What is the needs? The challenges that they're facing. We talk about the commodities that are being created. Is it electricity? Is it hydrogen? Is it synthetic gas? Is it water, wastewater processing, etc.? The amount, of course, of the to be processed, the size of the facility needed, the feedstock, the sources, existing waste disposal infrastructure, and then use the market. So we're going to sell that too, right? Our strategy in WPP is to provide an ultra-modern alternative waste disposal and energy production system. We know that the market is very large. They haven't seen anything that has processing or has processed the waste like we do. The EPA study that we've done meets all the requirements from the standards in Europe, Central America, the United States, as well the process is to eliminate the urban solid waste. Here's an example of the plant. I want to point out here is a substation that we also build. We'll talk about storage areas, and back here is the plant. I will talk a little bit more about the plant a little bit later as I have some more drawings. Here's the dual Thurman technology. As I mentioned earlier, it is pyrolysis as well as plasma. And it's a quantum leap over the waste processing systems today. It reaches the temperatures of about 1600 Celsius. It liquefies the solids. It does not burn them in any way. Let me slow this down a little bit. Okay, these are the type of waste that we process. As you could see, we'll take anything from plastics all the way to medical drugs and Sharpies. Very important, ashes from incinerators. If you have existing ashes from an incinerator that's polluting your neighborhoods and your rivers and your streams, bring them to us. We'll process those and make something out of them. They don't have a high calorific value, but we'll process them and turn them into slag rather than something that's damaging to the environment. This is a steam generator process flow. So you can see here, we'll input the waste in this chute here. We'll push it into our first thermal unit. We'll process it. Then we'll create steam in this boiler to run the generator. And it's dual here. This one, I didn't stop it, but here we go. Let me pause it here. This is a syngas feed to a power plant, for example. So you saw the earlier one. This is steam. This is syngas. Our partners, Siemens and Baker Hughes, the SSE series are terrific series of gensets. And of course, the steam turbines from Baker Hughes, so GE as well. Here's an incineration versus Dorex on the test results. What I want to point out here is the weight 2 to 1 here, 10 to 1 in ours. And the volume, we reduce the volume, right, quite a bit. So what comes out is very little in comparison to what went in. Again, here are the results. As you could see, the O2, the NO2, the dioxin interference, all below the levels of the EPA requirements. Here's an example of our toxic waste or non-toxic waste residue. This is a slag that can be used to build roads. As a matter of fact, we talked about building bricks from these to build houses and roads, etc. Here's another example of a plant. And I point out the storage area here for a couple of things, but water as well as the LNG that we need to run it. And we'll talk about removing this from our infrastructure as well. So we know that the landfills are polluting the local environment. As a matter of fact, I just came back from not too long ago from an island that they had 22 landfills and they're closing 17 of them because they have no place else to put their waste. So it's a huge problem nationwide and worldwide. But some of the things that it causes, right? The poisoning, the low birth weight, and the congenital malformations and neurological diseases. So it's important that we address those issues. Here is this. I'm going to pause here for a moment because this is of interest. I think it's 12 units that we provide, from 2 tons per day all the way to 400 tons per day. The generation of electricity from 0.77 megawatts to all the way to 12, almost 14 megawatts of electricity. This is consumption that is internal to the unit, but I wanted to share this here because it's a lot of information here. This is the calorific value. I want to share this with you because this, let me pause here. This has the value of the waste that is processed. So if we're talking about MSW, for example, the highest moisture, the lowest moisture, you could see the difference in calorific value. And this translates directly into electricity generation, as you can see here. Let's see. Here's another look at the plant itself. This substation here will be able to handle the generators coming. See the gensets here. Here's another look at it from the side. This is the water. We use about 20,000 gallons of water to process. And every day we have to generate about 10% of that, actually 25,000 gallons. So we need to generate every day about 2,500. So that's what the tanks are here for. Here's an example of a waste to energy plant in Brazil. And this one, as a matter of fact, went to one of our customers there, and it's working very well. It's a pharmaceutical. It's important to talk about the tariffs as well, because you're going to be able to import tariffs and what they are. You might want to look these up in your specific countries and find out what the inputs are, the cost of the inputs to put into your financials as well, and we'll help you do that. This one here is this is important because it's the components of the unit. So we have the disposal area, we have the shredder and the waste preparation system, we have the feed system with the solid, liquid, paste, etc. And let me go back to that because that's an important one. The thermal units, the fusion module, and the plasma gasifier, and the peripherals, the scrubbers, the protectors, the collectors, and then the monitoring and control center, very important because this is what runs the system. Here is what I wanted to talk earlier that I said that we cannot outsource this part right here. The thermal unit and the plasma gasifier. Everything else here can be done locally through an EPC, and we'll be able to negotiate that and help you lower the cost, the OPEX and your CAPEX. We have a maintenance warranty. That is 2 years after the equipment has been installed. It's important to know that we offer an extended warranty as well that needs to be purchased. It's 10% of the cost of the warranty. That needs to be purchased after the installation, because if it doesn't, then it is void. Okay, so as soon as it is installed, we need to purchase that extended warranty. We'll talk a little bit more about this, but there's a lot of information here. When you download the presentation, you'll be able to see it. This one is the extended warranty that I mentioned earlier. It's up to 3 years, and it's 10% of the original purchase price as reflected on the original invoice. Make sure that you know and understand what that means. Here is the training. We offer up to 40 hours of theory, as well as 40 hours of practical training, depending on the type of unit. It's a 2 tons per day. It'll take more than 8 hours to go through that, right? But we're talking about Borax Orion, which processes 400 tons of waste per day, and that'll take a little bit longer. Here's what I mentioned earlier. This one's being delivered and assembled at one of our clients in Brazil. So you can see how modular it is and how easy it is to install it. Talk a little bit about our mission and our vision, because we want to make sure that the world understands what we're about, what our company is about, and what we want to do to be environmentally friendly in our methods of waste disposal and be a solution to the growing demand of renewable energy and clean water. And our mission is to provide a global sustainability through innovative and environmentally friendly technology. Make sure that the world takes advantage and starts destroying our environment. Here you will find some videos that will show you our technology and working. You could click on these and we'll take you to a YouTube channel where you'll be able to see them. Our team, myself, you'll find a little bit about myself here, a little bit about Troy, who's the Chief Operating Officer, as well as Jacqueline. Jacqueline Young is our Vice President, very knowledgeable, very astute woman. Imagine that if you are engaged her in any way, you'll see that she is a terrific person. Our contact information, in case you need to get in touch with us. We offer a worry-free operation. So we ask you to take the first step, reach out to us. We'll do an MOI and LOI and make sure that we provide everything that you need to make your project successful, specifically for it to be profitable, because it's very important for it to be profitable. And we look at the profitability point of view as an ROI of less than 5 years. That would be ideal for us. That's it. Any questions? We'll take the questions.
Felix, is it okay if I add something here?
Please do.
Okay, so I wanted to let everyone know that WPP is working on creating a global showroom. So this is really breaking news from WPP. So the UK division of WPP has stepped forward and essentially made a bid to become the global showroom. So just outside of London, by June or July of next year, we should have a global showroom set up, which will be a waste to energy version of Borax. Now, it'll either be a 10-ton, a custom 10-ton to include an energy delivery system. Normally, the energy delivery systems only begin at the 22-ton per day model and go up to the 400. But this will be a custom built for showroom purposes. Presently, people can come into Brazil to see our working model there. They can see our manufacturing facility, etc. But we hope to have high degree of traffic coming through our London showroom starting in, could be as early as May, certainly no later than July, according to current forecasts.
Fantastic. Good to hear. European friends will be glad to see that and have a place close by. They don't have to travel all over to the other side of the world.
Exactly.
Yeah, that'd be great. Let's see. Anything else here that you want to mention or talk about? I have no questions here. Let's talk a little bit about financing. So in finance, I'm sure you heard on, I think it was Monday or Tuesday, a couple of folks from the World Bank discussed the financing options and the fact that there are no projects, or very few projects that they could finance in the waste to energy and renewable energy field. And I want to tell you that we have quite a few projects in our funnel that need financing, and we'll be glad to talk about financing. As I mentioned earlier, these things, ROI is less than 5 years, and they work very well in the and the fact that we can return your investors money that soon is really remarkable. So I encourage
Yeah,
you
and Felix,
to have that discussion.
I'll add something here as well. So the WPP distributor base, as I said, consists of about 40 distributors, product resellers. The distributor base and the end clients have access to what we believe to be the largest grouping of project funders, technology funders assembled today. So in the password protected online library of data that the resellers have access to, there's a list, I believe it's now 50 or close to 50 firms which are active in funding green energy and environmental waste energy technologies. So we have partnerships with several of these. We have a partnership with a major Chinese investment bank, major American investment bank, numerous others, Southeast Asia. So as long as the economics of a waste to energy project are sound, and the financier will be more likely to be comfortable to go ahead and fund the deal. Similarly, on the 2-ton, 4-ton, 5 and 10 tons that are really focused on non-waste to energy applications, waste treatment, say for example, medical waste, coronavirus waste, pharmaceuticals, biohazard,
Right.
chemical, this kind of thing. As long as the waste is there and there's a waste contract, then they're likely to fund. But we recognize that a lot of technologies don't get adopted because of the failure to fund. So we have excellent resources in place to assist end users get the funding they need.
Great. Thank you. Thank you very much. So the fact is that we're looking for projects. The technology is viable, is here, is available, ready to rock and roll, as we say. So we're looking for projects to roll out, and we'll work with you. We have a complete group of distributors that are very knowledgeable in this area that could work with you and to bring these projects to fruition. And what can we say? You take garbage and you turn it to electricity. You turn it into another sub project instead of being as a matter of fact, I wrote a paper on the fact that we should look at waste not as garbage, but as a renewable energy product. So as a renewable, garbage should be known as renewable, as a renewable source, not as waste itself, because it really is. And depending again on what type of waste we're talking about here, right? Because each one of those tires, for example, and plastic, etc., are very good for electricity production, but not so much the high moisture units, right? So anything else you want to add, Troy?
I think maybe we'll just close by pulling back the curtain a little bit and letting people know where the name Vorax actually comes from. So it was inspired by the word voracious. So voracious meaning it's very, very hungry. So Vorax dreams of being deployed at a landfill site or near a landfill site. Vorax is like the hungry guy at the buffet. Vorax wants to eat 24/7. So even if you put it by a landfill site, even when the trucks aren't flowing, when the waste is not coming to Vorax, if it's near a steady source of waste, it can continually be fed by a loader and through the conveyor. So this Vorax comes from voracious, and the more you feed it, the more energy you'll get. That's really what Vorax is all about.
Well, that would leave it at that. Thanks so much, Troy. Appreciate your input. And Irvin, we could exit here and let us know what else we need to do.
I'm going to sign off and thank you so much, everybody. I'll turn my camera off and we look forward to hopefully some robust dialogue, questions we can field outside of the chat window, and we'd be happy to talk to any businesses that are interested in carrying our product line as well.
Thank you, Troy. Appreciate you.
Bye.
Let me exit full screen here and let me exit out of here.